Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Ease of oxidation of alcohols follows the order: primary alcohol, secondary alcohol, tertiary alcohol. Phenols are oxidized but under harsh conditions. Ethers are very resistant to oxidation, and tertiary alcohols are not oxidized under normal conditions. They would require C to C bond cleavage. Moving on to the next step. Identify the functional class of each option. A. CH3 CHO. CH3 is to propanol, isopropanol, a secondary alcohol. Secondary alcohols are oxidized readily to ketones by common oxidizing agents, example, K2Cr2O7, KMNO4, PCC. B. The structure shown is a phenol, hydroxybenzene derivative. Phenols can be oxidized, but require stronger or specific oxidizing agents. They are less straightforwardly oxidized compared to simple aliphatic secondary alcohols under typical conditions. C. CH3 CH2O. CH2CH3 is diethyl ether. Ethers are generally resistant to oxidation under normal laboratory conditions. D. The structure is a tertiary alcohol, 1-methylcyclohexane, 1-ol type, cyclohexane ring with both CH3 and O on the same carbon. Tertiary alcohols cannot be oxidized without breaking C to C bonds, making them the most resistant to oxidation. Moving on to the next step. Rank the options. Option A. Secondary alcohol easily oxidized to a ketone, propan 2-1, by mild common oxidizing agents. Option B. Phenol can be oxidized, but not as readily as a secondary aliphatic alcohol by standard reagents. Option C. Ether very resistant to oxidation. Option D. Tertiary alcohol cannot be oxidized under normal conditions. And for the final step. Among all four, the secondary alcohol, option A, is oxidized most easily because it has an alpha hydrogen on the carbon-bearing O and no bulky substitution preventing oxidant axis, and it converts cleanly to a ketone. Why other options fail? B. Phenol requires specialized oxidants and is not oxidized as easily as a simple secondary alcohol. C. Ethers lack the easily abstractable alpha hydrogen needed for typical oxidation pathways. They are oxidized only under vigorous conditions. D. Tertiary alcohols have no hydrogen on the carbinol carbon, so standard oxidation, which requires CH cleavage at that carbon, cannot proceed. Therefore, the correct answer is A. Therefore, the correct answer is option A.